is we're a monthly meetup. We meet talking about Google technologies, Android, cloud, startup, all sorts of things. Find us on meetup.com. There's slides that I don't know what they are, so I'll try and keep up with them. So that's our group. We've grown a lot in the last few years, and it's pretty exciting to see this growth. I signed on to help start this group after going to Google I/O in 2009. I think Google I/O is the big developer conference that Google puts on. 7,000 people now come every year, and it's really inspiring. It's a couple days of just super inspiring talks and people doing really interesting things. And I thought if there's any way I could bring this level of energy back to the Twin Cities, I want to get tied into that somehow. And it's happening. There's already a great ecosystem here in the Twin Cities of developers doing really awesome things. So it's great to be part of that. Today, I wanted to thank a number of the organizers who made this event possible. We've got Stephen Fluen, Stephanie Trimble, Patrick Fuentes, and Jeff Williams, who is taking the bus from Mankato or something. We don't know where he is, so I need to talk to him if anybody sees him. So I wanted to also thank this event couldn't have happened. It's a huge undertaking, so huge thanks to all the organizers. They put in a lot of hours, and definitely huge thanks to the sponsors to make this event really happen. We've got some really great prizes to give out to people throughout the day. This venue is great, and to try and make it affordable for everybody was our goal. And so I wanted to thank our sponsors and there's a couple sponsors. We wanted to give a moment to say a word or two about what they're doing. So we'll start with Target. Did I give them the wrong time? Maybe they'll come in a second. So Target and Lead Pages came in at our specially named the platinum level of sponsorship and really made an impact on making this event possible. Anybody from Lead Pages? Do you want to say anything about Lead Pages?
Sure, just real quick. We're one of the fastest growing startups in Minnesota. We do conversion rate optimization. We're mostly a Python and JavaScript shop, but we're getting into a lot of other cool stuff. Big data analytics, really pushing the bleeding edge on what you can do in the browser. So if you're interested in finding out more about us, just look for anyone wearing one of these t-shirts. Love to talk to you.
And if you love app engine,
Yeah, that's right. If you love app engine, we're the place to be.
Thank you. And they're also sponsoring our the after party tonight. There's information on the site about that. I see Target people showing up. They missed the shout out. Do you want to say a couple of sentences? Or?
Sure. Same thing for Greg. We're also hiring. So if you want to talk to any of us, we're all wearing our shirts. There's some developers obsessions. We have a booth. We have some great chargers. If your phone battery is getting low, we'd love to chat.
Thank you. So we're in the next tier, Augusto. Is Paul here yet? No one from Augusto? Augusto's been a great sponsor for us throughout the year, hosting events and space and being our annual sponsor, as well as stepping up for this event. So thank you, Augusto. Code 42. Code 42 also is our kind of longest running event sponsor. We meet there. This last year, we've been going back and forth between Augusto and Code 42. Definitely two of our BFFs for G2G Twin Cities. So next is BuzzFeed. Phil, do you want to say a sentence or two?
we're happy part of DevFest. I'm Phil Wilson, general manager of BuzzFeed here in Minneapolis. We're in the tech shop, hiring iOS, Android, front end, back end, full stack, you name it. We're strictly tech, no editorial, no sales. So we've got a brand new space. We'd love to have you come out, and we are hiring. So glad to see you. And of course, we're on the third floor. Not much, One thing we do well at BuzzFeed is swag. So
Thanks, Phil. And then Live Front. I know Mike couldn't make it today. Oh, great. All right, super. Thank you. And all of these sponsors have booths around, which leads into my next. We have a little bit of an experiment this year. So one of there's so many great announcements over the last year with Google-related products. One of them being Firebase joining the Google team, and so we've been trying to do more integration with Firebase as just kind of trial things. So today, we've got a scavenger hunt. We have, what's controlling this? You? Can you pull up the Google Cloud endpoint? Just do a Google search for Google Cloud endpoint. This is professional level presentation here, people. All right. So this logo, which they're hiding, there it is. All right, so there are scavenger hunt endpoints hidden around this event today. There's sponsor endpoints, product endpoints, so different cloud products, and some hero is what I labeled them as. For instance, on my badge here is an NFC tag. I tried to cover all you Apple folks and do QR codes, but it was just anyway. So NFC is so cool, and anybody with an Android phone that's NFC enabled, does anybody want to try? Way up there. All right. Do you want to pull up? All right. Next page is seek.devfest.mn. Well, you have to unlock your screen. Yeah, well,
okay.
you know.
Okay.
All right.
Come on.
Oh.
Oh, no.
Slash.
Oh, I got a thing.
All right, log in. Leaderboard. All right, throughout the day, and make it a little bigger. So, by the way, I'm not a designer. But this is all running on Firebase. On the back end, we'll have a screen at different points throughout the day. I will either post to your Google Plus or send you an email that you've won a prize. So you, as the most recent person on the leaderboard, would you like an Android, little toy, or Angry Kitty? These are pretty sweet. All right. So that's our scavenger hunt. The other Skunkworks project we have is an Android app. So we've got our schedule running on an Android app that Patrick Fuentes has built. Do you want to say anything about it real quick? Like how to find it?
Yeah, it's on the Google Play Store. DevFest MN. Yep. And was made maybe mostly last night. So.
But it has the most current schedule descriptions. You can favorite sessions. Same as if you go to devfest.mn right now, it'll redirect you to our schedule site. If you log in with your Google account, you can save sessions to your agenda and then view your agenda just to see the sessions that you'd like to see throughout the day. That's what we're running on for our most up-to-date schedule is there. Those were the two things. That went longer than I had promised. But so next I'm going to hand it off to Stephen.
All right, so I'm here to talk about today's logistics, so just so that you guys know kind of where we're going and what's happening. So as you can kind of see here, and you guys probably saw on the website and in some of the announcements we made, we've grown DevFest this year. Last year we had 4 tracks. This year we've expanded that to 5 tracks and over 30 speakers. So thank you to all of our speakers. I think there's a lot of great content today. If you're trying to figure out where to go or what to do, we've got signs on all of the doors with the schedule for that room, and then we've got signs kind of strategically placed around, so you should be able to find one. Or you can download the app in Google Play by searching for DevFest MN, or just go to devfest.mn in your browser, and this will come up with, as we said, the latest schedule. Each of the tracks or each of the sessions are about 50 sessions or 50 minutes, including QA. Some of the speakers might finish a little bit early, but we're planning on about 10 minutes of kind of travel time between each of the sessions. The first session starts at 10 a.m., and then we'll doing 2 sessions in the morning, and we'll be breaking for lunch, and then coming back for 3 sessions in the afternoon. And then we will be closing up at about 5 here. Again, everyone coming back together for closing remarks. And you will not want to miss that, because this year, actually, let me jump back. Whoops. If you are on Twitter, you may see this tag. We're trying to use this for everything that we're doing, with the exception of something I'm going to talk about in a second, which is prizes. This year we've kind of gone a little bit crazy. Lloyd got a hold of the budget and said, more prizes. So we've actually split it into 4 different types of prizes. So the first one is random drawings. So we'll be doing a random drawing at lunch, and we'll be doing a bunch more random drawings at the end, closing remarks. So there's prizes there like smartwatches, cool things like that. The second type of thing, as Lloyd mentioned, is the scavenger hunt. So the people that are collecting the most people, we're going to check in at various points and see who's top on the leaderboard. And if you're top on the leaderboard, we're going to give you one of those prizes Lloyd talked about. The third one is a photo contest. So does everyone here have a Google Plus account? Good. Wow. I'm actually impressed. So there's an event page for DevFest MN this year. And if you add a photo to the event, and then look around at all the other photos and plus one the ones you like, we're going to be taking the top photo at lunch and then the 2 top photos at the end of the day, and those people are going to be winning, I believe it's Moto 360s. So that's a big deal. So take photos plus one other people's photos. If you have the Google Plus app, you need to pull up, just so that we're all doing the right thing, you pull up the app and you click on the menu and hit Add Photo. And then that'll go into the event photos repository or gallery, and then you can kind of click around and plus one those. So we're going to be looking at those. It's got a leaderboard kind of built in. So hopefully we're going to see a lot of great photos. And then the last piece here is surveys. So we're going to be announcing 2 surveys throughout the day. The first one is for all of the sessions. So we've got this one URL, devfest.mn/survey, where you're going to select which session you were in, and then you're going to rank it on several criteria. And what we're going to be doing is, once again, we're going to be taking a random selection from all these surveys that people have filled out. And then those people will be winning prizes as well. And then our grand prize is at the somewhere along the day, we're going to be announcing a URL for an event survey. And then of all the people that fill out the event survey, we're going to be giving out a 2015 Chromebook Pixel. So that's a pretty cool laptop. I've got one and I love it. So, any questions on the giveaways, how to participate? So I know it's not just a raffle. So we're looking for audience participation. And a note for those volunteers and speakers in the in the crowd: you guys are welcome too. We really see this as a community event, and kind of everyone can participate. What else? If you need any help throughout the day, there's a bunch of us wandering around wearing blue shirts. So some of us are organizers, and we also have a fantastic team of volunteers. So a huge shout out to all of our volunteers. But just feel free to ask, start a conversation. I think we're all quite friendly. With that, I'm going to turn it back over to Lloyd to introduce our keynote speaker.
Thanks, Stephen. I realize I project and then also have the microphone, so sorry for the double projection. I'm thrilled to introduce our keynote today. Martin Omander is his name. Google. It was tricky to come up with a good way to introduce Martin, because he's behind this mystical awesomeness of working at Google. I end up talking with him often in my role as the lead here, and then a regional lead of GDG organizers. So it's just Martin, right? But Martin really has a phenomenal background and is really, actually, I would say one of my modern day heroes. So Martin comes from Silicon Valley. He went through the startup circle. It's been almost your 10-year anniversary at Google, according to LinkedIn. This is where I found this information. And currently, he manages the North America G2G organizers as well as a couple product reps. And that, boy, I can't even imagine or express the amount of work that must be. Because organizers, volunteer organizers are something else to manage. They're super excited and a little bit like herding cats. Their raise is not dependent on their performance. So that's... But they're great. It's a great group of folks in North America organizing G2Gs, over 100 of them. And also, which Martin, just as his nature, never really mentions these other things that he's working on, but he also hosts a YouTube series, Road Access for Startups, which is phenomenal. There's about 60 episodes so far on YouTube. They're about 8 minutes long. I recommend you watch all of them before the day's over. No, I'm kidding. But there's a great selection of them. And I'm a big fan of having modern-day heroes. I think you should be aware of who you work with and who inspires you and who's doing something that you aspire to work towards. And I'm very sincere in saying that Martin is one of my modern-day heroes. I'm pleased to introduce him.
All right. Thank you. I have this one. I have.
Oh, you got that.
Yeah. All right. Hey, everybody. Can you hear me in the back? This thing works? Yeah? Good, good. All right. Let's see if this works as well. So, my name is Martin Omander. I'm originally from Sweden. I grew up there, and it feels a bit like coming to Minneapolis. I came here last year. Lloyd invited me. It was February. He didn't say anything about the temperature. But it felt a bit like coming to sort of Nordic sensibilities, except people speak English instead of Swedish. But it feels like a little bit like coming home. So I come from Sweden, went to school there. My first job was back there. And then moved to Silicon Valley 15 years ago and worked at a bunch of startups. And the startups usually, they usually fail and go under about a year after I join them. So, then I got out of the startups, and 9 years ago I got into Google, and Google is still holding, so I haven't been able to sync that one. Let's see, can we get the projection there? Maybe like that. Thank you. So I'm going to talk about aspirin for the developer soul. So this talk will be based on trends. And actually, before we even go into trends for developers, there is one very important thing. My manager has to approve my expense report, and he's not quite sure if I'm eating 300 meals today, or if I'm actually having, if you all exist for real, or if you're just my imaginary friends. And I just bought this very nice little camera from HTC that connects with my phone. So I'm just going to pan over you, and then if you could all wave to my manager, and then you could sort of shout out, "Please approve Martin's expense report." That would be great. So I'm going to start over here, and then I'll pan over, and I'll sort of do like this when you should start, okay? So we'll start over here. Very good, very good. One more time, please. Very good, thank you. Now we can get into the actual talk. Yeah. There we go. All right. So information technology is changing, of course. I'm going to talk about 5 trends that I have noticed. I write code at Google for internal tools. And I talk with the people who write Gmail and the search engine and the folks who create the developer-facing, the APIs and such that you guys are using, like App Engine and so on. And I go to a lot of meetups as well and try to stay up to date. And there are 5 trends I've seen that change the way we work with information technology, and they can be real headaches. Fortunately, there's aspirin for them, and Dr. Martin here today will prescribe what kind of aspirin you need. And not only will that make the headache go away, it'll actually give you superhero powers, a special kind of aspirin. So the trends, if only I'd had a Chromebook, then all this would have worked. Yeah, there we go. So the trends are internet attention spans, amount of data, data changing. The fourth one is sort of a double whammy of some prices falling rapidly, but expectations going up at the same time, and then more frequent code deployments. I'll go through all these in some detail, and how they can be headaches, what the aspirin is, and I'm going to grant you superpowers for each of one of these today. So peering into the future, the first trend is that internet attention spans are short. And we all know this, and this has been going on, and attention spans in general have shortened. It took, for each new technology, it takes shorter and shorter for it to, from sort of being an incubating technology to being out there for everybody. So for example, radio took, something like 40 years for it to become really common. TV took 20 years. Computers took even less. Wearables now took like a year. So this is being compressed. And this is also true for the systems we build. This has real impact for what we build. Because this means that all of you are most likely seeing bumpier traffic in whatever systems you're building, bumpier usage than before. You see a lot of it and then not a lot. If you're in a startup, somebody writes about you on TechCrunch and your traffic goes off the charts. Or even if you write internal company applications like I do at Google, everybody hears about your tool and wants to use it, and then it sort of goes away and people don't know about it until the next corporate meeting or whatever. So big bumps in traffic. Now this is hard to plan for. Well, and actually here as well, here we see the Google Trends charts for Twitter. Twitter had a nice long runway of 6 years or so from being created to reaching its peak. And even so, do you remember the days of the fail whale? Anybody here remember? Yeah? Okay, great. That was even with that nice steady slope there. They still weren't able to scale up quick enough. Well, then Snapchat comes in, and they had the same growth that Twitter had in Twitter had 6 years to deal with. Snapchat had to deal with in 2 years. And the next, I don't know, Lead Pages perhaps will have a year to deal with that. And the next startup after that will have 6 months to deal with that. We're seeing amazing compression. Morse law of the mind, yes, that's true. So how do you even plan for this sort of thing, right? Twitter had a big problem planning for this. And even if you write internal apps, this is hard to plan for. I pulled the data from developers.google.com. This is the website where all the API samples and API documentation is for Google APIs. So here we see two trends. We see something like 9 valleys here that correspond to when it's nighttime in the US. US has the largest number of developers in the world, so US is the single biggest contributor to traffic to developers.google.com. We also see this other trend of right in the middle, we have 2 days that are a little lower than the other days, and that's because it's a weekend. So this is kind of hard to plan for this sort of data, because on Saturday night we have maybe a quarter of the traffic that we have on a busy Monday right after lunch. And all of us are seeing this in our systems and apps we're building. So going from 1/4, so from 25% to 100%, what kind of hardware should you have to support that? Should you have so you can deal with 100%, but then it's idle most of the time? Should you, what happens then when there's a traffic spike? What happens when this happens, for example? Here we see a bit of lumpiness, but then on November 12th, there's a huge spike. So now, all of a sudden, we don't have a 25% to 100%. We don't have 4 times more traffic on the spike as on the weekend, but this is more like 9 times the traffic we had on this particular day. You're all seeing this in your systems as well, and this lumpiness will only increase. So, okay, do you have twice the amount of capacity you need in your system, and most of it sits idle? Even if you do that, you are not guaranteed to be able to handle those extra spikes. So this is enough to give an IT person a headache. No matter what, you either end up wasting money or you end up not being able to deal with your customers at peak times. Well, fortunately, Dr. Martin has an aspirin for you. So what you can do to deal with this, and this happens for my applications. I've written some small applications that are external to Google, and most of them are Google internal, and I see this lumpiness as well in traffic. And I'm not an IT operations guy. I'm a programmer. I want to write code, upload my code and data, and I don't want to deal with capacity planning and all that stuff. It's just, it's no fun, and I'm not good at it. So what you should use is what lead pages are doing. Use App Engine. So this is a Google product, part of the Google platform. And what's cool with this is you can run your Python, Java, PHP, Go code on it, and it adjusts automatically. So you end up paying only for only for the blue area here. As there is a traffic spike, number of machines you get, we automatically, our system, no human is involved, our system automatically installs your application on more machines, and then as it drops off, we uninstall it from machines. You don't even notice. And it will look something like this. This is one of my internal apps. It doesn't have a lot of traffic, but here you see the spikes. That's a batch job I had running that went out to some external website, meetup.com actually, and pulled in data through their API. And here you can see at the bottom, I have 2 instances running. So that is 2 servers. Google system thinks that 2 servers is about right to deal with the load you have. And I can shut them down, or I can view. I never actually go into this menu. I just took a screenshot here because I wanted to show you. Usually I just let it run, and it figures out how many servers I should have. Oh, and by the way, on this slide, down in the lower right-hand corner, there's a nickel. And I put that as a reminder to myself. That is because 5 cents, that's how much it costs for you to rent 1 server for 1 hour. You also get the first server completely free. So you pay a nickel per hour per server for every server beyond your first one. So if your application only needs 1 server, you can go, it's free the whole time. So with this, I hereby bestow superpowers on all of you. Use App Engine, and when your boss comes and says, oh, we might have a traffic spike, you'll say, it's handled, no problem. And some folks who have used this superpower to good effect, and I'd love to talk with you guys later on lead pages, what your experience has been. Some folks who have used this superpower already are the ones we saw in the graph earlier, Snapchat. They built their whole application. So this is this application, you've heard of it probably. You take photos, you can send photos to others, and then the photos are deleted automatically after a while. So they actually built Snapchat and had this huge growth without having any IT operations staff. They had, last time I talked to these guys, they had 9 developers on staff and served millions and millions of users. And here you actually see their CTO. He is saying that App Engine enabled them to focus on developing the application, and they couldn't have gone where they went before. So Bobby Murphy is their CTO on the left-hand side here. The man who looks slightly worried there on the right-hand side is Urs Hösle, who is the head of infrastructure at Google, and his team has built up all this great infrastructure. All right, that was the first trend. Second one, and this is a trend which actually isn't recent at all. This trend, we're peering into the future. The best way to peer into the future is to look to your past, to our past, our collective past. And this trend has actually been going on for not years, not decades, not centuries, but millennia. There has been more and more data, and the amount of data we have grows exponentially. And computers has, of course, as you know, accelerated this growth. So we see here, you may have seen this infographic. This was the folks at Domo put this together about what happens in a minute on the internet. So, for example, there are 4 million search queries every minute. People upload 72 hours of video to YouTube. I can't imagine. I mean, how many cat videos do we need? I don't know. A lot, I guess. So there's a lot of data being generated. Also, in all your applications, here's a challenge for you. You have applications running, and you could all know more about your customers if you collected more data about their usage. So if you take one thing away from this, is regardless of what product you use, whether you use Google's products or others, go and log everything that happens in your application so that you know that this is the screen in your Android app where people abandon the flow, or this is the page on your website where people drift off, or they usually click this button and not that button. Collect, and it's fair with modern tools now. It's fairly easy to collect all that data. Google Analytics on your web page, certainly. You can have Google Analytics in your Android app. Similar tools from other vendors, of course. You should collect way more data than you know what to do with, because sooner or later you will figure out what to do with all this data. However, now you have this huge pile of data and you need to run analytics on it. And that is hard. If you get a lot of data, which you all should, it is expensive to run queries on it. You don't want to run queries on your live database. You will get to a point where your regular SQL database won't be able to handle it. Or if you are using NoSQL data, then it's pretty much impossible to run queries on it in the first place. So you might be able to collect all this data, but what do you actually do with it? How do you actually make it useful? It's a headache, and IT departments of all the big companies are fighting this, and it's a hard problem. Fortunately, Dr. Martin has an aspirin for you. And I'm sure that there are lots of good aspirins out there. I know of the Google-branded aspirin, if you will, so I'm going to show you that. This is BigQuery. This is Felipe Hoffa, by the way. He's a funny guy. He works at Google, and except for looking like he stepped straight out of a 1970s sitcom, he's also great at BigQuery. So BigQuery is this thing where you take your massive data sets, your log files, huge data sets, or you can stream data one record at a time into it, and have millions of rows in it and run super fast queries over it. And the 2 pennies there in the lower right-hand corner, that is there for a reminder for me. Let's see if I remember now. Yes, 2 cents is what it costs you to store 1 gigabyte of data on BigQuery for a month. So it's quite a bit more affordable than if you were to build machines and maintain machines yourself. Let's talk about Wikipedia. Wikipedia, they generate a lot of data. And what's really cool with Wikipedia is that they take all these change logs of articles, and they put the entire changelog in one huge XML file that they publish monthly. So all edits on Wikipedia for a month, that is a lot of data. And it's kind of hard to crunch those numbers. So, but I'm going to do it right now and show you how it can be done. Demo. So here is Wikipedia changelogs this is from a couple of years ago when we captured this data. It's 314 million rows of data. So there we go. 340 million rows of data. So this would typically, your regular SQL server would have a hard time running queries over this. What we are going to look at here is, here you can see the query text, or actually we'll do like this. So we select the top 10 titles from the Wikipedia set, and because we want to see which articles were the most edited articles. And it's going to go through the 314 million rows of data. So this is a couple of years old. I suspect if I ran it today, it would be different. Any guess, and I'm going to run this query with 314 million rows. Any guesses what might be the most edited article? Good, good, good. You're onto something, yes. What politician? This was a couple of years ago. It was surprisingly not Barack Obama. Should we run it and see? Oh, Clinton. Oh, good guess. It's not. We'll run the query. We'll find out two things. First, ooh, Putin. Good. That's inspired. It might be if I pull this data today. Yeah. My hotel Wi-Fi didn't allow me to download this data last night, so I'm not completely up to date. So we're going to find out two things. One, what's the most controversial subject on Wikipedia? And two, how long does it take to query 314 million rows of data? Okay, ready. Here we go. Oh, one more thing. We should not cheat. So here it says use cached results. We don't want to cache anything. That would be plain cheating. No cached results. See that? Yeah. Look, Ma, no hands. All right, it's taken 1 second, 2 seconds. Will this ever finish? There it is, 2.8 seconds. And the most edited one was George W. Bush, 43,000 edits. And number 2 really threw me. What? Yeah, number 3, it's sort of recursive in a nice way. Yeah, Wikipedia. All right. So a regular SQL database would have had a hard time with this. A NoSQL database, you wouldn't have been able to do it at all. Okay, here's another cool data set. So this is MLabs, or the Measurement Lab. This has been founded by a bunch of folks who are in academia. And one big company, as Google, participates as well. The thinking behind Measurement Lab is that you should, if we're going to make good policy for the internet, it's not enough to just have opinions about, oh, network neutrality this, or peering is good, or peering between ISPs is bad. You need actual hard data about how, if ISPs are discriminating certain websites or not. If speeds are fast enough for everybody in the US, everybody in the world. So these folks are in the steering committee. They founded Measurement Labs. The guy on the upper right-hand side is Vint Cerf, who is the only guy at Google who wears a suit. And he can do whatever he wants because he invented the Internet Protocol in the early 70s. And when asked what every talk I've been to when he's speaking, he says, he gets the question of what would you have done differently if you had designed the Internet Protocol today? And his answer is always, I would have created a far bigger address space. So these guys are really smart, and they put together a lot of data. And the way they do it is that they have a plugin you can put on your web server that measures everybody who comes to your web server and how fast their connection is. So this thing is out there on 32,000 servers, measuring every single connection that comes in, and it generates a lot of data. So here we have a data set that's roughly 1,000 times bigger than the Wikipedia data set, 240 billion rows. When you have this larger data set, you will want to see that, for example, that it is consistent, that these 32,000 servers, who is creating these 240 billion rows? Is it just a few of these servers who are running most of the tests, or is it fairly evenly spread out? How many of the different tests in the test suite is each of these servers running? These are hard data problems to deal with when you have 240 billion rows. Fortunately, I loaded it all up, and not on the hotel Wi-Fi, mind you. And we're going to check it right now. We're going to do a select over 240 billion rows. Look at this query. So this is a little more complex. Not only is it 1,000 times more data, you see here that we have two inner queries. So we select number of tests, and number of tests, and then number of clients who performed that many tests. So there are a couple of hundred different tests you can do. And then we select by IP address, and after that we do raw select on the whole main table. This is the one, so the Web 100 log entry. This is the one that has the billions and billions of rows. And then we do a bunch of filtering, and then we do group by on each of the queries. And finally, a big order by here at the end. 240 billion rows. Let's have a look. Also, if you just be quiet, I will just mumble a quick prayer to the demo gods. Please make this work. Oh, and we should also turn off the cache, of course. Let's see. Okay, 1,000 times more data than the last test. The last test took 3 seconds, roughly. So if this takes 1,000 more times, it will take an hour. So we'll run into the next session then. So Lloyd will probably come up here and interrupt me. Also, I will, if it's going to take an hour, I will run, I'm just warning you, I will run out of good stories to tell about Norwegians. Let's run it. Okay, 1, 2, 3, 4. Is it ever going to finish? It's a little scary with these. You know it's just a JavaScript thing here, right? You don't know if it actually runs. Oh, it did. 8. That was actually faster than on the hotel Wi-Fi. Let's see if we see some. Oh, yeah, there's good data, too. So here we see that 4,000 of these 32,000 websites ran one test only. 6,000 ran 2 tests. 14,000 ran 3 tests. So we can feel good that there was a sort of a bell curve here. We see that then drops off. So we feel good about this data. We can make policy decisions based on this data because most clients ran at least 3 tests. So here is where I grant you all superpowers, because you can do this. If you ever thought that your log files were too big, no problem, just dump them in here. If you have clickstream data, other data, that's a lot of data, then just dump it in here. If it can deal with 240 billion rows, it can probably deal with your data. Also, as a funny side story about this, a lot of these tools I'm showing off here today started as Google internal projects. This started off something like 8 years ago, internal to Google. And because Google, we needed to look at our log files, right? And you couldn't dump our log files with, 400 millions of queries every minute. You can't just dump it into a SQL database, because we want to find out what was the most searched for term, for example. And with that many queries every second coming in, we can't dump it into a SQL database. So we built our own tool, and of course it was a Googler who built it, and they were really into renovating, fixing up their house. And this was a great multi-purpose tool that could analyze log files. So he called it Dremel. So that's what we call it internally at Google. Of course, we can't call it Dremel externally because Dremel belongs to somebody else, that brand. So it's called BigQuery externally. So some folks who have used this superpower is Safari. So these are the guys who have online computer books for developers. Who here has used Safari online with their books? Oh yeah, okay, great, a third. Cool, I love them, it's great. They had a problem though. They have all this clickstream data of which books are people looking at on the web or on mobile devices, and which pages are people looking at. And this, as you imagine, is a lot of data. But they want to have not just a report they produce at the end of the month, but a UI that you can click on. So this is actually a screenshot of their clickable interface where their business folks can go in and see that the title that got the most clicks recently was the Ruby programming language book. And the previous hour, it was the 30-day MBA and so on. And then they can click through and they can see sort of real-time reporting because as things are happening on the Safari website, they stream that data into BigQuery. And then when the user clicks here, they run this BigQuery, the queries on it. So very cool use case. All right, let's see. That was 2 trends. The third one, this is interesting. This is also a trend that has been going on for centuries and millennia. So thousands of years ago, people were carving the laws of the land into stone tablets, and that's why we still have them around. And the transactions that merchants did in ancient Babylon was done on clay tablets that were then baked, and you couldn't really change it. And as data, as times went on, data became more and more mutable. And this is really exciting because if data can change faster, it means that it's a lot more useful. And there are companies doing great things. And I would argue they are successful just because they understand how to deal with rapidly changing data. So here's an example. This is Uber. I love Uber, and I use them all the time. Who here uses Uber? All right, okay. More people have read Safari books online than Uber. This was fascinating. I walked out of the hotel this morning. The doorman said, "Oh, can I get you something?" And I was like, "Yeah." I was going to pull up, Uber on my phone, but I asked him to get a taxi for me. And it took him longer to run around and get a taxi than if I had just done it here, and the car would have shown up. So what's cool with this is that for those of you who haven't used Uber, this is an app. You say where you are. Well, your phone always knows where you are, so you don't have to tell it. You say, "I want a car," and then it tells you you'll have a car in 2 minutes. And these black splotches here, what looks like black rectangles, are cars. These are the available cars. So if you step out of your hotel and it looks like this, you know that this is great. I have something like 8 or 9 cars right around me. So if I click, "I want a car here now," I will have it in 2 minutes. What's fascinating with this is that if you actually run the Uber app, you will see these cars moving, stopping at traffic lights, turning corners. So Uber is keeping track of not only where the cars are, but their speed and what direction they're going, and sending this out to millions and millions of users. So they keep track of millions of cars. In real time, they send that data to the users, which gives them which means that the Uber app is awesome and is so much better than having the doorman get a cab or call a cab company because they don't have real-time data. Amazing technology, but this is not really what we're used to. We're not used to having millions of users out there being updated on our data every second. This is hard. It's hard to maintain it on the server. How do you deal with the connections out there to the clients? How do you feed data to them? You need to build a huge server farm if your clients are going to poll your database. It just gets messy. And this is the kind of headache I felt when I tried to build systems that did similar things. Especially also game applications are really hard when you need to send game state out to lots of users. Really hard stuff. Fortunately, Dr. Martin has an aspirin for you. And the one in this case is Firebase. So this is really cool. Lloyd or Stephen mentioned it earlier. I have many good friends who work there. They actually left Google about a year or two ago, and then 6 months ago, Google bought Firebase. So you can try to leave Google, but you can try. So what's cool with this is that these guys have APIs so that you have your real-time database and you send out updates to your users and on iPhone and Android or JavaScript clients. And there's a $50 bill down there, and that is a reminder to me to tell you that $50, or rather $49, is how much it costs to enable your application with this. That buys you 200 simultaneous connections. So you can have 200 clients connected to your application at any one point. Now, the guy I know most actually best, who went over and headed up Firebase developer relations team, I asked him, so what is Firebase? And he said it's a real-time database. And I was, yeah, okay, but what does that mean? I mean, even in other databases, you can, in a SQL database or no SQL database, you can change data and then read out the changed data right away. So what does it actually mean? And I think the only way to show this, well, to show it, is to show it. So let's play some computer games. Here we have, this is on the Firebase website. We have a code sample here. This is a Tetris game that is written in JavaScript that runs entirely on the client. So you see here they have, let's see, we'll just go down a little bit. They have various block colors, the shapes and colors of the pieces, the initialization, some rules. All of this is code that deals only with the rules of Tetris. And we just keep going, keep going, keep going. I'll go a little further. Somewhere around here, there's database stuff going on. Rotate. Oh, no, I missed it. Let's go back. So this writes to the Firebase database. If you can't see it in the back, let me tell you, it's a method declaration and one line of code. This reads from the database. This actually requires 2 lines of code. So let's play Tetris. Now, I warn you, it was a long time since I played Tetris, so I'm not very good at this. But we'll see here. Okay, cool. Where should I put it? Where should I put it? Corner? Oh, okay. This one. Ooh. Right next to it. Is that right? Okay, good. All right, this. Oh, no. What should I do? Like that? Okay. But then over here, but I lock that one in. Over here? Okay, great. Oh, do you think I can slide this in under the other one? Let's see. Yeah. Oof. I'm clearly playing. Oh, look at this. I think I'm going to beat my high score here. Actually, if you'll excuse me, I'll be playing this. We can continue after the break. So what's cool with this is that this is a Tetris game. I can play it. It's just in my browser. But it's actually a 2-player game. So, and this is where... So over here, we have player 1. Player 1 can affect the outcome in this over here, and where it's white. Here's player 2. Player 2 can affect the outcome here, but he sees what player 1 does over there. So player 2 is not doing very well. Well, actually, neither of these players is doing very well. Fortunately, it's a forgiving game. It just starts again. So this happens with those 2 lines of JavaScript. Not only are these 2 clients kept in sync, but they also, and we'll look at this. This is the database. So here we have player 0 and player 1. Here we see what the board is. Here we see, and this is changing in real time, as you see. So we can do neat things here, like change the board in real time. Oh dear, this is not, yeah, okay. Restart it all over again. This is better. So now look at the board. Okay, so now look at the bottom line over here. I'm going to cheat. This is my favorite way of playing Tetris. Green, 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 green. Green, green, green. Boom. I just created a row of green. That's how programmers play Tetris, okay? So this is obviously great for games, and 2 lines of code to enable this game and do real-time data. So now you know what it means when I say real-time data. And you now have superpowers because you can do this when others can't. And some of the folks who do this is Twitch. This is a strange company. I would never have understood that Twitch would be a big company, but this is basically the guys. You see the picture over there in the upper right-hand corner, a bunch of guys playing video games, and it's like video games as a spectator sport. And they're worth billions of dollars, and they did a God of War marathon last night. This is what it looked like. My son loves it, and clearly he is more of their demographic than I am. Amazon bought them for more money than you can shake a stick at. They, however, it's all about real time for them, right? So they use this Firebase for their various live updates on their website. Real-time data. Data changes faster than ever before. Okay, here's another one. IT hardware prices keep dropping, but expectations on all of you keep rising. So what this means is you can buy all the hardware you want, but, and hardware has come down in price. This is the hard disk you've been waiting for. So hard disks, and I guess today, you probably can't even get a thumb drive that's 10 megabytes, right? And it certainly doesn't cost $3,000. But at the same time, you haven't become cheaper, or developers haven't become easier to get. We heard all these great sponsors are here today. Every single one of them is looking for to hire people. So what that means is that computers have an easy time of it because you can just buy more of them, but you can't buy more of the programmers, so you can't clone yourself. So there you are in the middle of the night drinking coffee and working way too hard. So here, and this is headache-inducing, I can tell you, especially, we've all done those all-nighters. The way to deal with this headache is to you need to become more productive. And the Google Cloud Platform, I would argue, helps you do that. There are various products here. We can talk about it later, about what each product does, because you can store and you can compute, and there's everything you need there, SQL, NoSQL, various services, machine learning APIs, so you don't have to come up with that yourself. But the main point here is that you don't want to be on the top curve here. Because if you're building your own private cloud, you will be at the very top, at top left of this graph. Not a good place to be, because it's super expensive. Even though your hardware is practically free, your time, or the time of the person installing that hardware and maintaining it, isn't free. So top left, not a good place to be. Bottom right, a great place to be. Most of you are not working at companies installing 100,000 servers. So, but you can easily get on board with a company that does. So Amazon does this, Microsoft does this. I would argue Google does it, and better than anybody else. Bottom right, good place. Top left, bad place. And don't be afraid of, a lot of people are saying, I can't be on the public cloud because everybody can see my data and so on. So that was a valid concern years ago. Now cloud computing has become mature enough that the Google Cloud has all of these various certifications. And I'm sure others are working on their certifications as well. Even HIPAA compliance, that is for like healthcare data, you can store that, no problem. So superpowers, become more productive, and the way to do that is to go with a cloud platform from a large vendor. If you ask me, I would say Google. If you ask somebody else, they would say somebody else. Because you can become more productive. Best Buy, they went with Google. And they have a large development department, so they measure these things. And they said that they take 10 to 20% of 25% of the resources to run a project on Google's cloud compared to doing it themselves. And most importantly, it takes only 1/4 of the time to build something on the Google cloud versus doing it themselves. Also, if you're concerned about Google Cloud losing important data, you should be really scared right now, because 65% of the Fortune 500 companies in this country do their SEC filings through Workiva. And Workiva is App Engine all in. They were one of the first ones. So if you own any mutual funds or any stock, chances are your data, well, not your personally, but the company's SEC filings go through Google App Engine. And I've been doing it for years and years without you knowing it. So be nice to Googlers, especially if you see Googlers who are, what do they call SREs? Site Reliability Engineers. These are the guys who keep the servers up and running. If you ever see one of those, be nice to them. Buy them a beer. The entire, the entire stock market might hinge on it. All right, last trend, more frequent code deployments. So this is a great trend and a scary trend. It's great because we can fix our mistakes faster. If we deploy once a month, deployment becomes very scary. If we deploy once a week or once a day, deployment becomes less scary. Except this is what a typical environment might look like. You have all these machines. You have a team A and team B. They have their own development servers. They have their own integration servers. Then it needs to go into integration environment, test environment, staging, production. All of these machines have to be maintained, and all of them, and every single arrow in this graph is super scary, because no two machines in this graph are exactly the same, no matter how hard you try. Team A will use version 1.1 of a library. Team B might be on version 1.2, and nobody discovers until it hits QA. Or Team B wants another version of a library that has a conflict with something that Team A uses. Or somebody forgot to update the staging environment with the latest runtime of whatever your environment is. These things add up. So while it looks very nice and clean here, this is really a lot of work. And every single arrow, super scary. I know, the company I worked at before Google, we had deployments once a month, which meant that having them that seldom means that they're a huge deal and they're really scary. We would get online, everybody would be home, but we'd have to go online at midnight. And then the operations guys would start deploying code, and then things would start breaking. And it would be 3 a.m., it would be 4 a.m. All us developers had to just sit there at our computers and wait for the operations guys to tell us that, hey, this new code you deployed didn't work. What might be broken? And try to figure that out at 4 a.m. No fun. So I'm going to talk a bit, so it's headache-inducing, but there's aspirin. I'm going to talk a bit about the container engine and Docker containers. Who here has heard of Docker containers? Oh, great. That's the largest I've seen so far. Wow. You're way ahead. So this is an alpha. You see here the Google Trends for Docker containers. 2 years ago, there was nothing. Now it's super hot. And what I'm going to talk about here is a bit of the future. Those of you who raised your hand might know parts of this already. Those who didn't, I am bestowing superpowers on you right now, because you will be 2 steps ahead of everybody else. Very few people, there's a lot of talk about containers. Very few people actually know what they mean. But you will have you will have a conceptual understanding of this, and you'll be ready to start digging into it if you so choose. And it's only a matter of time before many, many of us will be working with this. You'll be 2 steps ahead of them. So containers are kind of like virtual machines. You can take a virtual machine, operating system and everything, bundle it up, make it a nice image that you install on a machine, on a physical machine. Containers are kind of like that, but you bundle up not the operating system, you bundle up your code and the libraries. So remember those two teams where one team used version 1.1 and one other team used version 1.2 of a library? They can continue doing that because they bundle up their own code and their libraries. And then there's a very strictly defined interface to that container. What can go in, what can go out. And this has been around for some time. It's just that with Docker, the company and the open source project, it's now become more widely used and actually get some traction outside big companies. So you've all seen this. Oh, a developer would say, oh, yeah, it ran on my machine. I don't know what's going on. Yeah. We depend on version 1.1. DLL hell. I guess this is a DLL still used on Windows? I haven't been on Windows for a while. Yeah. Anybody who knows what DLL hell is, raise their hand. I know. Oh, yeah. Okay, good. Yeah. Because you have a DLL, that's a different version, and then it conflicts. Okay, so it's hard for developers. Containers help solve that. It's hard for IT ops people, and I'm not an IT ops person, but I would say it's probably harder for them because they just take what I as a developer give them, and then it doesn't work, and they get to stay up all night. And they don't have a clean handoff from developers. Containers tries to fix all this. Okay, so here, this is the important slide. If you read this slide, and I'm going to take 2 minutes to explain it, you will know more than 80, maybe 90% of developers out there. Docker, what is that? It's a company, it's an open source project, it's a container format. But basically container format, which means you can bundle up your code and your libraries in one neatly deployable package. Great traction. Docker is well and good, but if you have many applications, you should typically have one Docker container per application. So if you have many applications, most of you do, then you will need to have many Docker packages. You will need to orchestrate them and deploy them in the right order on the right machines, have them connect to each other so your various applications can talk to each other. Then Docker isn't enough. Then you need something that orchestrates your different Docker images. And that is where Kubernetes comes in. And this is a Google open source project. Google started it, but Red Hat, Microsoft, a bunch of other companies have contributed to it. This is very cool stuff. You can download Docker, the Docker open source code today. You can download the Kubernetes open source code today and play with it and install it on machines. However, for most people, you don't want to mess around with the Kubernetes source code. You don't want to know all the details of Kubernetes. You want to just use the capabilities Kubernetes gives you. And the way to do that is to use Container Engine. This is our way of saying, okay, here's the open source project. Now we'll just bundle it up nicely and put a nice GUI on top of it. So you can click and point and click instead of writing commands. And we deploy it on machines for you. So you say, I want, 10 Kubernetes machines. So if you keep these three apart in your head, you know more than most, than 90% of developers. Container Engine, because Kubernetes is kind of new, Docker arguably also new, we are still experimenting with this at Google. And nobody should leave this room thinking that they're going to put their production application on Container Engine. It's an open alpha right now, so you can go in there and try it out for free right now. But don't put your production apps on it. I expect that later this year, maybe next year, we will have had enough input from the community to know what to fix, what to change. We'll have lots more fixes, contributions to Kubernetes from Red Hat, Microsoft, and the other big players. And Container Engine will be able to go into a version 1.0. But for now, play with it, and you'll be 2 steps ahead of everybody else. And you'll be a superhero. And big companies have used this for a long time. At Google, we used containers for 10 years. It's just that we did it in our own special way, and it wasn't open sourced. And Netflix did the same, and eBay did the same. All these big companies have used containers for a long time. It's just that we couldn't all agree on what the format was, and Docker made us all agree, which is great for all developers. So we launch a lot of containers at Google every day. And I had a really good point I was going to make there. And that point, I think I will have to make over beers tonight. I hear we're all meeting at the, what is it, Marina Restaurant? Okay, very good. We'll meet there. Your job is to come to the bar and ask me what my very good point is, and I'm sure I will remember after about 2 beers. So quickly, this is, I think you should all look at, some of these things apply to you. You have big data or changeable data. Some of it doesn't. You should all look at what's up here. Your next step should be to investigate one of these cool technologies, and you'll be a superhero. And when are we starting the next sessions? 10 minutes. Oh, wow. I thought we started at 10. We even have time for questions then. Any questions about this? I warn you, if there are no questions, I'm going to shoot you more video of you. Do we have the folks from Lead Pages still here? They left? Oh, how do you like App Engine? Yeah. Great. That sounds great. I love it. It's also always a bit scary when you ask somebody like that. You don't know if they're going to bring up, yeah, but that bug in Python 2.7. Yeah, let's talk in the bar about that. Yes, yes. Good. Any questions about this or anything with Google APIs in general? If I don't know the answer, I'll make one up on the spot. Yeah. Do applications need to certify or declare themselves so that they can run on Docker? You need to define it as a Docker package so that the Docker container knows, like Kubernetes, so the Docker container knows that it is a Docker package. Other than that, I haven't played enough with it to know the details around that. Yeah. All right, if that's it, I thank you very much for your time, and come up and ask me if you have any questions later.
All right. So as we said, we're pushing back the morning schedule a little bit, so everything
Can you hear me, Sean? Does that sound? Yeah. Sam? Does it sound like it's coming through? A little closer? How's this? Yeah? All right. Well, so we're supposed to start at 10:10, right? Should we wait a couple minutes? Okay. Oh, no, it's just, yeah. We got to get the new one up there soon. Still wait, yeah. Yeah, I don't know if there's like,
Morning, everyone. Let's get started now. So I'm Brian Yencho. This is Sean Weiser. We are from LifeRun. We're going to talk today about apps for Android Wear. I'm going to focus on custom UI. So if you're not familiar with Android Wear, this is the smartwatch platform developed by Google, sort of based on Android. There's an emphasis really on notifications, as you can see in this video here. If you've ever used Google Now, it's got these Google Now style cards, and you have a stream of them. And it's really kind of based on these glanceable interactions. What you might not know is that you can also have full screen, full apps running on Android Wear. So here's an example here, InstaWeather for Android Wear. Every platform needs all of its weather apps. Android Wear is no different. Wear Tip Calculator is a popular Android Wear app. It's just got a really nice UI. Kind of takes advantage of the round watch face, if you happen to have a round watch. This is a fun one. Adapedia basically sources its information from Wikipedia and presents it in a kind of usable form on the watch here. And so something to notice with all these apps, they're all full screen. They're all different, and there's really no restraints on what they're doing. And that's because Android Wear really is just Android. And that's just the coolest part about Android Wear. You're not given like a template that you are allowed to fill in. You can kind of do almost whatever you want. And that's really great. So if you already know how to program for Android, you already know a lot about how to make an Android Wear app. So what it comes down to really is it's not about how can you create apps and how can you create custom UI, but how should you do it? Because watches are not smartphones. And if you go online, Google has some nice sort of documentation about design guidelines and best practices, but they really boil down to these two things. Android Wear devices can be square or round, and they're small. Again, they are smartwatches. Because they're square or round, you really need to create your layouts in a way that is aware of what shape your watch is. And because they're small, you need to make sure to keep the information density low and to use sort of big, easy gestures. Google provides a support library, the wearable support library, which sort of codifies the best practices for use with Android Wear. You don't have to use it, but it's really a great tool. So what I'm going to be talking about is sort of like the different nice classes that are provided by this library that help you make really nice, easy to get started Android Wear apps. And something I do want to point out, this Wear library is subject to change. It's not like a traditional API where sort of once it's set, they're not going to sort of change things from underneath you. They'll kind of build upon it. This can just change. And you might even notice if you look at the documentation, sometimes the documentation can be out of sync with the current state of this library. So if you ever try to just jump in and get started, it's just something to be aware of. A few of the classes that I'm going to talk about today are kind of listed here. There's a bunch of others that come as part of the support library. I'm just going to kind of hit the basics and the most important stuff. So let's start with shape-aware layouts. So here we have a square watch and a round watch. And let's just put a very basic, simple layout right in there. Let's say you take a frame layout, put a circle in each corner. Looks fine on the square watch, but if you look on the round watch, the corners are getting clipped here, because really this layout isn't designed for a round watch. If you try to fix it for the round watch, let's say you add more padding to make sure all those circles kind of get in there, then you're going to be ruining it for the square watch. So a really basic tool that's really great for this is called box and set layout. So what box and set layout is, it's a wrapper around the layout that you want to show. And what it allows you to do is, for a square watch, it keeps everything the same, but for a round watch, it allows you to add extra padding. And you do this with this attribute called layout box. So what I've done here is I've taken my original layout, wrapped it in box and set layout, and I've applied layout box to every edge of this layout. And so on the square layout, you get sort of the same thing as before, nothing's changed. On the round one, now you get extra padding. So now this layout works for both round and square watches. And you have some options with this. You don't have to put your padding on all of the edges. You can pick and choose. You can specify left, right, top, bottom, any combination that you want. So this just kind of gives an example of what happens if you were to do it on, the top, just the sides, or all of them. Now, that's not the only way to kind of handle shape-aware layouts. Another class we have is called WatchViewStub. The idea behind WatchViewStub is, okay, maybe you don't just want extra padding. Maybe you want two completely different layouts when you're dealing with a square watch and a round watch. So what WatchViewStub does is really, it's just points to two separate layouts. You have these attributes here, rect layout and round layout. You just set those to two completely separate ones for whether you want, on your square or round watch. So here's an example here. I'm starting with the same basic WatchViewStub, and now I'm getting two completely different layouts. And the way this works is it's going to do a runtime check to see, all right, given this device, is it square or round? And then it has to figure it out. Then it lays out from the light the correct layout. But because of that, you have to wait to interact with your views if you need to make any modifications. So there's a callback, set on layout inflated listener. So if you need to do anything, any modifications to your views, you use this callback, and then once that's triggered, then you can kind of do anything that you would normally do with your views. All right, so box and set layout and WatchViewStub tend to be the root of any layout you're going to use when you're making an Android Wear app, because they're just very helpful, and you need to solve this problem all the time. So for all the examples that I'm going to use moving forward, box and set layout is what I'm going to be using. All right, so another design pattern that's very common is cards. And again, the whole notification system is based on these Google Now style cards. And the support library gives you the ability to create cards yourself as well for your custom apps. So there's a couple of ways to do this, sort of depending on, do you want to deal with fragments or do you want to deal with views? And I've just kind of given two examples here. So the first way is card fragment. Card fragment's nice if you just want to get a card out there with some very basic information. So you can specify a title, text, and an icon. You just create the card with those, add it to your layout, and then you're all set. So here's an example here where I do just that. You also have the option of where you want to pin the card. If you want to pin it on the bottom of the screen or the top of the screen, just kind of let it float. That's something you can set programmatically. Card frame is a little different. If you want to deal with views instead of fragments, you can use card frame. And this actually, you get more flexibility from doing this, but there's also more work. So you have to start with your root layout. You have to put it, the next thing is a card scroll view, which if your card is too big, allows your card to scroll. Then you put your card frame. Then within your card frame, that's where you finally put whatever arbitrary content you want to be using. So just here's an example here of all the nesting. You got your box and set layout, card scroll view, card frame, and then some layout. But then once you hit your layout, it can be whatever you want. So I've just kind of done these sort of cascading text views there. And with your card frame, you can kind of do some of the same things you can do with the card fragment. So you can pin it to the top or the bottom. You can kind of specify that programmatically. But that's something you actually do on its container, which is this card scroll view. All right, so lists. Lists on Android Wear should, in principle, work a little differently than a list on a smartwatch. So here's an example of a list you might see, just a system list. Going through some options, going through some settings. What you see is you really only have one actionable item at a time. And then as you scroll, it kind of sort of clicks into place. So it's really based on, you just want these big gestures, low content density, one thing you can really act on at a time. All right, so in the support library, they provide a new class that kind of helps you do that. It's called Wearable List View. So here's my example of a wearable list view implementation for a demo app that I'm kind of using throughout. You got the same thing. You can animate these icons, make them bigger. It's got kind of the same snapping behavior as you scroll. You only have one actionable item in the center at a time. So let's take a look at how we can implement this. There's 3 pieces. You have the list view itself. You have the adapter, and so at that point, it's pretty much the same as using list view or recycler view. But there's one extra piece here, which is an optional listener interface you can use, this on-center proximity listener. And I'll kind of show you how to set that up in a moment. So let's add this in. So let's take our box and set layout. We'll just put in a list view, just like you would with any normal list view. For your adapter, when you implement it, it's pretty much just a recycler view adapter. So if you've ever used the new recycler view class, you already know how to set up this adapter. So you have an onCreate view holder, onBind view holder, and get item count, and that's all you're required to implement. And just like the recycler view adapter, the sort of view holder pattern is baked in. So you need to implement your own view holder as well. And then just here's a really quick example, just where our view holder is just going to hold a text view. Now at this point, just setting up the list view and setting the adapter is enough to get all that sort of snapping and nice scrolling behavior. But if you want to go one extra step and implement this listener interface, you have 2 methods to implement, on center position and on non-center position. So it's just a hook for when you go from switching from center to non-center and back and forth. So the way this works is you're going to want to create some custom view class that implements this interface. So here I'm calling it demo item layout. It's just a linear layout. Implements the interface. And then in your adapter, when you're inflating your view for the first time and on create view holder, you just use this custom view. And then once you've done that, it'll just tie into the hooks that you've set up with the listener interface. So just here's a quick example. So for my list, what I wanted was to change the icon color from green to blue. I wanted to scale up the icon size, and I wanted to change the alpha of the text. So you notice one argument here. It's a Boolean animate. So this says, should you animate or not? If this is false, you should just set the final values immediately. So I'm just checking that flag, and if I should animate, I'm just doing really basic animations to go from the current scale to final scale. Otherwise, I'm just setting everything straight up. And then for the on non-center position, it's the same exact thing, just flipping the values around. And so again, just implementing that gives us this nice sort of list view behavior that is very similar to what the system's doing. All right, 2D pickers. This is another really fun design pattern. I really like this part of Android Wear. So if you've ever set up an Android Wear watch, this is the first thing you're going to see. So you have new items as you sort of scroll vertically, and then as you scroll to the right, you get details for those items. And so the support library provides a class that allows you to mimic the same behavior. It's called Grid View Pager. So here's an example of a Grid View Pager that I set up. So Guardians of the Galaxy was one of my favorite summer movies, so I just kind of made this 2D picker where you scroll vertically through characters, and as you scroll horizontally, you see quotes from each of these characters. Something you should notice is as you scroll horizontally, you're getting these nice parallax effects, and if you noticed before, as you're scrolling vertically, you sort of got these crossfades between the different images. So let's take a look at how to set that up. All right, so our Grid View Pager, just add it to your layout, just like it was a normal view pager. Easy enough. Then you have 2 choices of adapters you can use. This is just like a normal view pager. It just depends. Do you want to deal with views or do you want to deal with fragments? So that's just Grid Pager Adapter versus Fragment Grid Pager Adapter. So I'm going to choose Fragment Grid Pager Adapter my example here. So the main methods you have to implement are getFragment, getRowCount, and getColumnCount. So the only way this differs from a normal view pager is instead of one getItemCount, you now have to tell it how many rows and how many items in each row. The nice thing here is that this getColumnCount takes a row argument, so you can have variable numbers of columns. You don't have to have this uniform grid. Then you have these optional overrides, which are the coolest part, because these allow you to set up the parallax and crossfade effects. So if you want the vertical crossfade and then the horizontal parallax, you implement getBackgroundForRow, and you just return a different drawable for each row. Otherwise, you can do getBackgroundForPage, and then you'll have a different image for each cell in your grid, and then they'll all just kind of crossfade between each other. So just here's a really simple implementation of getBackgroundForRow. In my data model, just for each row, I have an image resource attached to it. Then I just get the drawable from there, and then that's all you need to do to get all that parallax and crossfade effect. So just one last time, just so you can kind of see it again. You get a lot for free just using Grid View Pager, and I think that's really just a really cool class to use. All right, so another design pattern, delayed confirmations. So let's say you have some big action that your app can perform. Maybe it's deleting a file. You kind of want a way for the user to cancel that if they made a mistake. Because maybe maybe you have big fat fingers. You can make a mistake. So what you do is you can use something called the delayed confirmation view. What that does is after you press the button that should take the action, first it pulls up this button. And this button has a sort of progress bar counting down. And if you count down to the very end, then okay, you've accepted it. You'll launch those nukes. You'll do your big action. Otherwise, you can press the button, cancel it. That gives them enough time to, not to make a big mistake. All right, so here is an example of a cancellation. I press the button, this thing comes up, I click it, just cancels it. Otherwise, if we just let it count down, you get a confirmation, and then your action happens. All right, so let's take a look at implementing this. So this view, you just add it to your layout just like any button, any other view you normally would. And then in the XML file, you have a bunch of customizations you can do. So you can customize the color, the size of it, what drawable you're using, customize the color and size of the progress indicator around the outside. Very customizable, very easy to use. Then what you do is programmatically, this is where you set your timer and where you start it. So here I'm setting the total time as 2 seconds. You set a listener interface, and then at some point you just have to have something that triggers start. Once that starts, you'll start counting down. So the listener interface that you're implementing here looks like this: on timer finished and on timer selected. On timer selected is what gets triggered when you actually click on the cancel button. So let's look at just basic implementation here. So for on timer selected, let's look at this first. So for my demo app, what I've done is I've set this canceled flag to true, and then I'm just showing a toast saying it's canceled, and then I'm closing the activity that this was in. On the flip side, if you look at on timer finished, first I'm checking my canceled flag. Did I actually cancel it? Because this on timer finish still gets triggered even if you click the button. And then in this case, if you remember from the animation, I'm sort of showing this sort of confirmation animation coming in. That's actually another class as part of the support library. This is confirmation activity. It's just a really nice way to just get a sort of standardized confirmation message animated in. All right, so the last pattern I'd like to talk about here is long press to dismiss. So if you take a look here, swipe to dismiss is sort of the system default behavior for dismissing something, because there's no back button on these smartwatches. So you have to have some way to close your app, close an activity within an app. So swiping from the left to the right will do that by default. But sometimes you have an app where maybe that doesn't work. Maybe you need, as part of your UI, to be able to swipe to the left and to the right. An example of this is Tinder, I believe, has a smartwatch app that's based on swiping to the left and to the right. So that's just not going to work for their app. So what you can do, you can set this flag as part of the theme. You just say, swipe to dismiss, just shut it off, turn it to false. But then technically, you don't have any other way to close the app. So you're required by the design guidelines to implement the long press to dismiss pattern. And they give you a nice helper view to do this called dismiss overlay view. The way this works is if you have this set up right, you long press anywhere on your activity, pulls up this view. If you click the button, that will then cancel your activity, close your app. If you click outside the button, that will just hide the button. To add this, it says one requirement more than most of the other views I've talked about. You actually have to make sure that this is the highest view in your hierarchy. It has to cover everything. That won't happen by default. You have to do it yourself. So you have all of your content, and then you put this on top. Then, in your activity, you need to implement a gesture detector to look for the long press. So here I just have this simple gesture detector that when it receives a long press event, it just calls show on the dismiss overlay view. And then one more step. You have to hook that gesture detector into the touch events of your app or your activity here. So I recommend hooking into dispatch touch event. That's going to get every touch event coming into your activity. So just filter it through that and just check, did I receive a long press? If so, trigger this gesture detector. All right, so here's an example. Long pressing there, button comes up, press the button, dismisses the activity. All right, so that's a basic introduction to the sort of custom UI that you can get using the support library. And now Sean is going to talk about custom watch faces.
Thank you, Brian. So as Brian mentioned, Android gives us a lot of power and a lot of customizability in how we create our wearable apps. Android also gives us a lot of power in creating our custom watch faces. The process is a little different, as we'll see in a little bit, but it still gives us a lot of power in terms of how it looks and how it behaves. So in the time that we have left, we'll briefly go into the basics of it, and then I will cover a couple customization options that you as a developer can give the user, and how you can actually customize it to use the system UI. Before we get into that, though, I want to introduce the concept of modes. There are two modes that we care about. The first is interactive mode. As you'll notice, this is the main mode. This is when the watch face is fully lit. The user is interacting with it. They're going through their notifications, looking at the time, acting on notifications. In this mode, you can do pretty much whatever you want. You can use as many colors, as many animations. The sky's the limit pretty much here. That is not the case, though, in ambient mode. This is when your watch is in standby mode, which is going to be most of the time. We're going to be using only black and white, mostly black, as you can see. The point here is to conserve as much power as possible. So as you notice, they've taken away all moving parts. Here in the interactive mode, you can actually see the second hand going. Here, they completely remove that. One of the reasons they do that is because in ambient mode, your watch face is only going to be updated about once a minute. So depending on what mode you're in, interactive or ambient, that's going to play a big part in how we actually draw the watch face. As I mentioned before, the implementation of a watch face is a little different than how to implement a regular activity-based app. The watch faces are actually implemented as services, so you're not going to be inflating views and messing around with that. Everything is actually on the canvas, so you'll do all your drawing there. Before we get to that, though, we need to do a little housekeeping. So for wearable watch faces, there are two permissions that we need. Provide background and wake lock. These need to be added to both the mobile and the wearable manifest. One thing to note is that any permission that you add to your wearable app needs to be in the mobile manifest as well. So after that, you need to actually register the watch face service. This goes into the wearable manifest. I don't know if you can see it very well, but some key things there are the Android name. That'll be the package and class name of the watch face. The label, that is the name that shows up when you want to pick your watch face. And then there's two more settings, two more properties that you will need to set. The first is preview and then preview circular about halfway down. These are just point to drawables that the watch face picker will show when you want to actually pick the watch face. Only the preview property is required. If your watch face looks about the same on a square device as on a round device, you only need to include the first one. You're free to include both, though, if you want to. So this is an example of the watch face picker. On the left, we have the actual wearable when you pick it on the watch. On the right side is what you see in the companion app on the phone when you actually want to pick a watch face. So for demo purposes, we created a custom watch face. It's very simple. All it does is tell time, and then once an hour, it goes and looks for the high temperature of the day, low temperature of the day, and the current temperature. It'll update highs and lows, and then the current time will then change the color to whatever the current temperature is. So just something simple that we can show off. So that leads us into some of the code. As I said before, watch faces are implemented as services. So one of the things we want to do is extend a class called Canvas Watch Face service. What we do here is override the onCreate engine method and return an engine. The engine is right here. That's just a private class that extends Canvas Watch Face service.engine. There are 5 or 6 methods that we need to overwrite and implement ourselves. We'll get into those. They are onCreate, onPropertiesChanged, onTimeTick, onAmbientModeChanged, onDraw, and onVisibility changed. So the first one is onCreate. So when you have a watch face, you don't want to have to keep redoing stuff that you can accomplish in one step. So one of the things to do in onCreate is to allocate and initialize all the resources that you want to use when you're actually drawing the watch face. You don't want to be doing this each time you call onDraw. So in onCreate, we're going to be configuring the system UI. We're going to be loading all the styles, colors, dimensions, pretty much any resources that we want to use. And we're going to save them up for later so that we can just grab them at any time. Here's some of the demo app. It's a little hard to read, but I think you can see it. So the first step we do is set up the system UI. We'll talk about that more later. The next step is loading all the resources. So we load any strings that we're going to want to use, any dimensions, colors, and images. The next step is to set up the paints that we're using. Since we're using a canvas, each distinct style is going to need its own paint. Next, we load load an instance of an object called time, and then we start to update the timer. So in interactive mode, we need our own custom timer. As we'll see later, in ambient mode, we automatically get a call once every minute to update the watch face. With your custom timer, you're probably going to want to update it more often than that. So we have to create our own custom timer. All that pretty much is a handler that calls itself every so often. For our custom app or custom watch face, we have it updating every half second, I believe, and that's to get the blinking colon effect. One of the other key takeaways here, we call a method called should timer be running. We only want the timer to be running if the watch face is visible and we're not in ambient mode, so that we're actually in the interactive mode. This is because if the watch face is not visible or if it's just in ambient mode, we're not going to care what the watch face really does. Next method is on properties changed. So depending on what device you're using, they can support different properties. A couple that we'll want to know about are a property called low bit ambient. When this property is set to true, the screen is going to support fewer bits for each color in ambient mode. In that case, we want to actually turn off anti-aliasing. That's pretty much all you're going to have to do with that property. Some devices also have burn-in protection when it's in ambient mode. When it does support that, it's going to shift the watch face around every so often just to prevent burn-in. And in those cases, the Google Docs actually recommend not putting content 10 pixels from the side. Otherwise, you're going to risk cutting it off. But if you don't care about that, go ahead and draw to the very edges of your watch faces. So there's a method called on-time tick. This gets called about once every minute. This is what controls when the watch face gets updated in ambient mode. All we do here is call invalidate, and the watch face gets redrawn. The custom timer that we had set before does not get called in ambient mode, so we have to depend on this. When we go in and out of ambient mode, it calls this method on ambient mode changed. All we're doing here pretty much is changing colors if we need to. In ambient mode, we want the background to be black, the text to be white. If we're not in ambient mode, all we do is set the correct colors for the text and any backgrounds that we have. And then at the very bottom, you can also see that if the device does support low bit ambient, we're also turning off anti-aliasing if we're in ambient mode. Another method on visibility change. This is what happens when the watch face becomes visible and loses visibility. There are two things to note here. We want to be sure about in the middle there, to call update timer. This makes sure that when the watch face does get displayed, it's up to date. The other thing that we're dealing with here is time zones. The service is actually registering a listener that detects if we've changed time zones since the last time. If we're visible, we care about that, and if we're not visible, we don't care about that at all. So we unregister the service at that point. That brings us to on-draw. This is where the most intense computation is going to take place. So hopefully you've set up everything up to this point in onCreate. Hopefully you have all your resources, all your strings, all your colors, everything that you need. Let's just go through this. At the very top, we set the timer to the current time, just to make sure that we have the right time displayed. Next, we're seeing if we should draw the colons. Then we draw the background. In our case, the background is just a solid gray square, so we can use the canvas method draw rect. If we're actually using drawables, and this is the first time that you're drawing it, you want to scale your background to fit HDPI devices should have a background image of 320 by 320 pixels. After that, we are formatting the string. If we're in ambient mode, we only want to display hours and minutes. If we're not in ambient mode, we get to show hours, minutes, and seconds. And after that, we just draw text on the canvas. If you have a more complex layout, you're going to be able to, you can draw shapes, you can draw images, you can animate stuff. As I said before, in interactive mode, you can pretty much do anything. The key point here is just to know whether you're in ambient mode or not. So besides that, there are other data sources that you can bring in. Our watch face pulls in data from a weather service, an open weather service that just updates the temperatures, like I mentioned before. These operations can be very expensive, though, so you don't want to do it on every tick of the clock. We update the weather information every hour. For our purposes, that's more than enough. We don't care that the high and low temperature changed on the minute. We can wait that hour. So if you are planning on pulling in other data sources, make sure you're doing it intelligently. Saying that, though, there are many things that you can actually do. Since the wearable is connected to your phone, you can make network requests. You can pull in all sensor data that the phone has. That communication is two-way, so it's beyond the scope of this talk, but there is ways to communicate between the wearable and the phone. So that brings us to customization. We're going to talk about a couple things. The first are system UI options you have as a developer to kind of customize how the watch face interacts with cards and status bar, stuff like that. The second thing we're going to talk about is you as a developer giving users an option on updating the watch face to their liking. As you might have seen from the code, in onCreate we have a set watch style call. All this does is this sets all the system UI options. There are about 12 properties that we can set. We're going to go through those pretty quickly here. The first is set ambient mode peak, or set ambient peak mode. That can be either hidden or visible. So in ambient mode, if it's hidden, no card is going to show. If it's peak, then we do get the regular card showing up. Set background visibility. There are two modes here. It can either be background visibility interruptive or background visibility persistent. If it's I should mention each card has its own background. If it's interruptive, it'll briefly show the background. You can't really, that's just a screenshot, so you can't really see it there. But if it's persistent, it's going to actually show it over the clock face. I'm not sure why you'd ever choose persistent. In case, yeah, I really don't know. Your watch face is not going to be visible at that point. There's a property called set card peak mode. You can either have it variable, so it's going to grow as the content grows, or you're going to have it short, which restricts it to that smaller dimension. If you do have it as variable, you want to make sure that your watch face still displays the relevant information. Here, we're cutting it close. We can still see the time. That's probably good enough. We don't really care if the temperature is visible, especially since the card that's peeking up is a weather notification. So wearables have something called a how word. If you can see on the bottom, it's the OK Google text there. You can move that around the screen depending on to best fit your layout. All that does is respect the gravity that you give it. So here we have top left, top right, bottom left, bottom right. As you can see, those on top best fit this layout. Anything with a bottom gravity kind of overlaps the watch face itself. We also have a set peak opacity mode. So if we do have our cards with a variable height, we can actually set it to translucent so we can see part of the background or part of the watch face behind the card. Just like we have the set how hot word gravity, we can also set the status bar gravity, so we can move that around the screen as well. The status bar is, all that does is indicate, that indicates whether it's connected to the phone and power. So here again, we want to probably keep that on the top. Set view protection. For our watch face, this probably isn't needed. Our gray background is probably dark enough. But if, for example, we have a white background, we're not going to be able to see the status bar, the hot word, or probably some of the cards. So what this does is it overlays or underlays a background on some of these UI elements. So the first one over here is protecting the hot word by showing a darker gray background. The next one is the status bar, and the other one is the full screen. So everything gets protected there. A couple other ones, set show system UI time. This will actually display the system time on your watch. So if for some reason your watch face doesn't actually show the time, but it's just the background, it will show this time there. And then the final one is show unread count indicator. This, all it does is in the status bar, it shows how many unread notifications you have in the stream. Okay, looks like we should have enough time. So the last thing we have is user configuration options. So for our demo watch face, it would be great if the user actually had the option to, say, set where what city, for example, the weather was being pulled for, or what units that we were displaying the temperature in. Unfortunately, we did not implement that, but we did grab one of Google's sample watch faces that does have configuration options. So what configuration options pretty much resolve down to are activities that get loaded onto the watch itself and the companion app. So let's take a look at those. So here's the companion app. So when you're selecting your watch faces, anything with configuration options has that little gear icon. You can see it in the sample digital one. And then once you load that up, it'll show all the configuration options that are available for that watch face. In the companion activity, you're going to have a lot more space. So you should be able to have show the user more options. It's hard to see here, but this gives the user the option to set the background color and then the color for each individual hours, minutes, and seconds. When you're using the watch face picker on the wearable itself, you don't have as much room, as much real estate, so you want to limit the actual configuration options. Here, all you're able to do is pick the background color, either blue or black. For our demo app, for example, in the companion app, we'd want to allow the user to select the city and the units in the companion app. But on the watch itself, probably just the units. The thing is, the wearable and the mobile app are always going to be together, so it shouldn't be too much problems to actually configure it on this phone itself. So those two watch faces, or that watch face that we used for the configuration, and all Google's example watch faces are available on that second link there, the sample watch faces. And then the first resource up there is a great guide to designing and implementing watch faces themselves. I highly recommend checking those out if you're interested. And that is Beyond Notifications. For Brian and myself, thanks for coming. Are there any questions? Yeah. It was an the question was, how much work was it actually to figure out the API? It wasn't actually that bad. The example apps are just a great help there, because while you have a lot of power over what you can do, the 5 or 6 methods that you have to overwrite kind of lead you down to a path that is kind of easy to understand and pretty useful. So I would say not very much at all. As I mentioned before, doing the watch face is a little different than a normal wearable app, since you're not using all the layouts and stuff and views that Brian talked about. I think they're different enough that depending on what you want to do, it may not make sense to start with the watch face. If all you want to do is the watch face, yeah, go right ahead. If you want to do app development itself, I would probably start somewhere else. Where was? Oh, yeah. Down at the bottom, yep. Thanks, everyone.
people hear me through the mic? It's a microphone. Try to get that up a little. Okay, I think we'll get started. Can people hear me okay? Hear me in the back? Cool. Okay, I'm Paul Lundberg. I'm from Augusto. We're a cloud development partner for Google, actually a premier partner based right here in Minneapolis. We're in the Ford Center, right across from Target Field. And we do a lot of things with Google. I'm going to focus today on our dealings in terms of cloud platform. And we have been diving into containers, just trying to understand, where is all this going and how should we be using it and where should we be using it. And so I thought, what better way to really try to get a grasp of things and to try to present, this information. So I think there's people here that can probably help me out. I got some T-shirts. Anybody that wants to participate, see if you clarify things, I'd appreciate that. I'll throw you a T-shirt. So let's get started. Just a little bit about me. Outside of development and work, pretty much what I do, play some hockey, do some cycling, do some mountain biking. In terms of Augusto, I'll just kind of run through our history. Back in 2011, we started to get a little bit involved in some development on App Engine, and that was because we had a lot of Google Apps customers that were asking us to do some development to integrate their Google Apps, whether that be Mail Calendar or any of the other tools that they're using, with their enterprise systems. So we started to do some development. Actually, our very first project was with the Nordic Ski Foundation here locally for the Lopet event, and we thought it was a great case study for App Engine because they had a lot of volume on about 2 or 3 days of the year. Actually, most of it comes on over about a 12-hour period when they send out all the registration information and everybody pegs the website to read about the event and download their information, and then everything goes quiet for another year, and then we do it again. And we've been doing that for them for about 5 years now, or since 2011. So I think this was our first time. So that was our very first App Engine app, and it was a fun app because you could just watch App Engine do its thing where we've got no computing instances running. The requests start coming in, and it scales up to handle the load, and when things quiet down, it just shrinks back down again. It was really, really fun to watch. And we'll maybe show that a little bit once we get my demo up and running here today. I'll just show you again that sort of sandbox container that App Engine offers. It's still just an incredible container in terms of performance and the way it can scale up and down. So in 2012, I attended Google I/O, and that's when Google announced Google Cloud Platform, and that included Compute Engine and a lot of other things. And it was really clear to me then, and some of what they presented, if you were there, was amazing to watch them spin up the number of cores simultaneously while we were watching the presentation. Just from a technical standpoint, just amazing. And I had a realization there that, wow, Google is definitely going to be one of the winners in terms of cloud platforms. We were doing Google stuff. We were happy with that, but it was at this event where we really decided, we're going to get serious about development on cloud platform. Google's clearly going to be one of the winners. They're making huge investments in this. And this quote here I love because you just get this feeling when you go out and talk to people at Google. When I've had the opportunity to be in some of the sessions with some of the product managers, they're just way out ahead. We kind of solve our problems day to day, and their workloads, what they're dealing with is so complex and so far ahead of what any of us has to kind of solve that they're innovating out of necessity. And so they're not looking at us as customers saying, what do you guys need today to do what you want to do? They're thinking about how are we going to possibly keep up with all the workloads and all the complexity that we have in terms of, our workloads and around analytics and everything else. So much of the innovation from Google, I think, comes from that. And, it used to be, let me see if I can get this back in presentation mode. It used to be back, I'd say, in that 2012 timeframe that my impressions, I don't know if it's reality or not, but I have a sense it is that Google was thinking about platform in terms of what do we need to run all of our services. And then there was a little group over here on the side saying, how could we bring some of these services to our customers? And they were very kind of separate groups. And so, Google is 5 years ahead here, and then we might see something come out. App Engine is the first thing that came out in 2008. Way ahead of its time, especially kind of funny because App Engine's all about containers, right? That's what it is. And here now this year, it's been about more than 5 years, we're all getting all excited about containers, so kind of proves the point. Last year, just a couple more quick points about our history. So last year we had completed our first highly scalable product development effort on platform, mainly centered around App Engine, but also involving some other components. And I had a chance last year to speak at the keynote for that at this conference. This past year, we for the first time licensed a framework around machine-to-machine that's highly scalable machine-to-machine solutions, and we were able to license that and build a solution. Actually, that's still in progress, in production, but in second iteration for a Fortune 100. And then this year, we're working on launching our own product, all centered on and running on Google Cloud Platform. So want to get a little bit of that Snapchat action if we can figure that out. So I just polled the audience here. How many people here on a day-to-day basis are engaged in some kind of Google-oriented development, whether that be Android or Angular or Maps? Okay, so probably half or so. And then what about experience developing applications on App Engine? Okay, probably maybe 25%. And then what about workloads on Compute Engine? Okay, so even less. Okay, that's interesting. Okay. Well, so here's what we've seen, in the last year. I don't think I have to, I thought I'd do the same thing Martin did. He had some pretty cool trending slides, so I quick pop those in here. So we have Docker software trending up. Everybody knows that. Google Cloud Platform, look, pretty surprising how much uptake they're getting recently, just in terms of people reading and searching around things related to Cloud Platform. And just to be sure this really worked, I went and did a couple more. So one of my favorite languages from the past, Smalltalk, I thought, sadly, still not trending up. It's trending down pretty steadily. So I'm going to have to let go of my Smalltalk. And I was happy to see Paris Hilton trending down. So it does work. So what I'd hope we could get out of this presentation today, understand current app dev on Cloud Platform. I just want to make sure everybody understands kind of the platform. And we'll talk about containers in the context of App Engine. We'll review where we are with containers today. And I'm going to do a demo around App Engine and managed VMs. And then we'll talk about some other container-related topics as well. So the platform. So we started with compute with App Engine in 2008, like I mentioned. And then there was App Engine, and there were some APIs, and that was about what we had. So, Google just kind of skipped way ahead, and, even though the world kind of wanted infrastructure as a service, Google was so far beyond that, they just decided they'd start with App Engine. They've since kind of come back and filled out the platform. So now it's incredible how things are changing and the offerings are coming. And I've had some, from our partner manager, some insights into the dates and things that are coming this year. And it's just astounding how much is going on the platform. So there's really, there's infrastructure as a service type workloads that are going on, and Google seems most interested in really large workloads. So we're talking to Google about getting involved in handling some of the genomic workloads, where you're just needing to spin up hundreds of cores or thousands to do processing. That's kind of the sweet spot. That's, in my view, what they're really after. But they have infrastructure for any kind of anybody that wants to put up a virtual machine or move those kind of workloads to the cloud. It's pretty straightforward to do. There's App Engine. There's a lot going on in big data, which is in the center of this talk, but that'd be another great talk just because of what's coming with data flow and some of the things that they're working on. Again, I think they're 5 years out, starting, and instead of waiting 5 years to introduce things, I think we're seeing them much sooner than before. So, one of the reasons, again, that I think Google is going to remain right on the top in terms of cloud providers is just that they're processing so much information, and probably more than anyone on the planet. So look at all the stuff they did this past year. This picture didn't used to look like this. Back in 2012 or 2011, when we were looking at where's this all going, it wasn't coming at us as fast. So this has been really encouraging from a company that's really placed a pretty big bet on this whole cloud platform and Google and what they're doing. Really exciting stuff. A lot of that we're kind of moving through from physical machines. Virtual machines would be Compute Engine in the cloud and what they're doing there, released in 2012. Containers, like I said, Google had that going in 2008. So they're working things backwards. Maybe they're going to start offering some physical machines here sometime soon. Maybe that's the Chromebox. Just another picture of kind of how this has progressed. We had Linux, and then we went into virtualization, and we all saw the benefits of that. Personally, I got my introduction to public cloud with Amazon. I had a bunch of servers in a rack and trying to run a small company, and got to move all those to the cloud and get rid of all those contracts with data centers and get rid of dealing with hardware and blinky lights. As a software engineer, it was a great day. I remember the day we took all the gear out of the racks and we took it to the IT recycling center, and we had a beer afterwards, and that was a good day. So hope to never go back to that. But now containers in 2014. For the rest of the world, like I said, Google's been operating container workloads for a long time. In doing my research, I was really surprised by how much influence Google's had in what this Docker thing is all about. Over the years. So first of all, Google's doing 7,000 containers a second, 2 billion containers per week. This is right from Google numbers I saw just from a January article. So this all got started back, in the world of trying to figure out how to do the container concept in Linux. And this whole control groups was started in 2006 at Google, and that became pretty core to the whole container concept. And this LXC is another key component to the whole Docker concept and making it work. And LXC was actually replaced by Docker with their own thing here. And I didn't know this either before this, but it was written in the Go language, which is really interesting. I don't know if anybody else knew that, but Go is a language that of Google's, and so the Docker lib container, which plugs in here to replace LXC, is written in Go. So lots of influence around this whole container boom. So just from that picture I showed you before, these are the areas on the roadmap here, or I should say, for the things that were delivered last year and just recently here that are related to containers. The thing is in red. So lots of things going on with containers, and probably a lot of the other features here around some of the logging and monitoring and everything else also relate containers. I think I talked about that. So let's just go into, just real quickly, Martin had a slide on this in the keynote, just to make sure we're all kind of grounded, is that really with virtual machines, we're running everything kind of on top of the virtual machine. And what containers is doing for us is allowing us to run many different containers on top of one OS. In this case, showing the Docker engine as the engine that's hosting those containers. So the advantages, we can run a lot more separate workloads on one virtual machine or one physical machine. Google runs theirs, from what I understand, on physical machines. We're all running, Docker's going to run in a virtual machine. So what that might look like for, let's say that you wanted to use Docker for your development environment. You would have your host OS and Docker running, and then I could run some separate things. So if when I deploy, I want to have these workloads separated so that I can deploy them separately and manage them separately, in my development environment, I could put together that same thing with containers. So I've got my workloads very isolated on my development machine. So I'll just talk about some use cases we have at Augusto for containers and how we used to do it and what we're moving toward now. So in the past, we would, like I said, we were very app engine focused. So we would always look to do things platform as a service first. That's where we start. And every once in a while, you hit some kind of a workload where we go, well, we can't really run this on App Engine because it's a sandbox container. It has limitations in terms of memory. Can't run any library I want in that sandbox. So what we did, what we would do a couple of years ago is we would just we'd fire up another cloud platform project, and we would build a compute engine instance, and we would put whatever we needed to do that we couldn't do in a container on that, and then we'd expose that as an API to our App Engine application that was running over here and scaling and doing everything nicely for us. Now that compute engine thing we were doing over here, we were back into the same things around infrastructure, thinking about, well, geez, what happens if this thing gets overloaded? Then what happens? Do we need to build our own scaling, and how do we monitor this thing? And what about updates? What about OS updates and all that? So we're kind of back into the infrastructure game, which we don't really like all that much. We do it when we have to. But there's definitely actually the first use case we had was Elasticsearch. We wanted to use that. It just seemed like the best way to do full text search engine for this particular application that we had. So we put that on Compute Engine and 2 separate projects communicating. It worked. It was fine. Maybe not ideal. Another case which we're actually dealing with right now is we have some image processing requirements, and ImageMagick is the kind of go-to for that kind of work. And we've built up, again, a Compute Engine instance that handles that, and we've made a RESTful service so we can invoke that, and it communicates with, it puts things into cloud storage and all of that. So where we're at right now with that is that it runs kind of as a separate Compute Engine machine. In a large project we're working on right now, we have a predictive analytics requirements. These are scientific computing algorithms using NumPy, and our customer actually has data scientists that are writing all the algorithms that they want us to integrate into our system. And we're not really scientific computing experts, so we've been learning quite a bit about that. But what we've learned is that these scientific guys, they get this stuff all working on a machine that's got a lot of memory, right? So they've got their workstation, and they go, hey, it works fine here, and we take it over to App Engine and try to run it with 1 gigabyte of memory, and it doesn't do so well. So we're starting to look to move those kinds of workloads into Compute Engine. actually manage VMs, and that's what we're going to kind of spend some of the time talking here about, is I want to try to help you understand what that's all about. And I'll use that predictive analytics as an example. So I should stop it. Any questions? Everybody kind of following? So back a couple years ago, Compute Engine really didn't have autoscaler. They currently have autoscaler. I think it's in beta now to allow you to do scaling of Compute Engine instances. So if you were going to just stay with infrastructure as a service, today now there's a way to do that. It's in, I believe it's in beta. Autoscaler, yep. Right. Right.
You could do that.
Yep, you could. Yep. Any other questions? Yes. This is a lot simpler than that, actually. We have PDF documents that we just need to rip into images. So we just have a high volume of those coming at it, where we have to, it's actually more processor intensive than you think it would be, but we take a PDF and we want images back. So that's what it is. We're also going to be using it for video, but we haven't actually tried to use it for that service yet. But any of those kind of libraries like that, it's not easy to necessarily get them running and functioning in App Engine. It's much simpler to just get them running. Okay. So when you say VM, are you talking about like App Engine sandbox containers, or limited to a gigabyte of memory? Yeah. Right, and so that's where managed VM. We'll jump into this here because App Engine works great for kind of those web sort of workflows where we just got small requests coming in, a lot of them, and we want to scale to handle those. But when you have a large amount of computing that needs to be done on a single unit of compute, that's when you need something more, something different, and that's where you'd. Right. Yeah, it's not the right tool for that workload, for sure. So you'd need to go to something where you could take advantage of Compute Engine, where I can go up to hundreds of gigabytes of memory if needed. I think the largest right now on the platform is a little over 200 gigabytes that I can request in a single Compute Engine instance. So should we talk about that more afterwards, or is that okay? Platform announced or has another feature that's fairly recent, and especially for us, and that's around modules. So what modules allows us to do is to run workloads separately, configure them separately, but run them in the same Google Cloud Platform project. So when I was telling you about, we have our App Engine workload and we have our file processing workload, and we have to be in separate projects, and we can't really put them together. We can't deploy them together. We can't monitor them. We can't, the billing, there's a lot of things where we've got two separate projects and services that are really for the same same problem, but we have to separate them. What modules allows us to do is start to put those things together into one project. So when I talked about this predictive analytics work, I could take and put, can define one workload around my event processing, and I can have another workload around predictive analytics. I can define those in the same project. I can deploy that all at once, which is really great. It was a nice step forward. We're starting to separate things out into modules a lot more than we actually thought we would, and it's simple to do, and it just guarantees that one workload is not going to interfere with the other, and that they'll kind of scale. It's interesting because our customers just think, well, even though they're separate, couldn't this impact that? And really say practically not, because the platform is so huge, and we've got these workloads separated. It's if this one's demanding a lot, it's not going to slow this other one down. There's other influences that are much bigger than our little workloads. Just to depict what I was talking about, where this predictive logic is being developed externally and we're integrating into the system. So a nice step forward here is to same picture, except now it says Manage VM instead of App Engine. So a Manage VM is really allows us to run to run an App Engine, which means that we're going to get the scaling up and down of these compute instances, and it also allows us to run it in a container. So now I can basically get the benefits of App Engine, but I'm able to run that and pick my compute engine type or specs that I need to run that workload, and it pretty much runs the same. Google supplies basically all the setup so that when I start this Docker instance up, I've got access to all the resources like data store and task queues and other things, other API services that I depend on. So it makes it really straightforward. So let's just kind of go into this in a little bit more detail and look at some files, and you'll get a much better sense for how this works. So these are the steps that we went through, that I went through before the demo that are already done. So just to give you a quick walkthrough of what we did here. So we installed the Google SDK, went through a few configuration steps, which are pretty straightforward. We installed the Docker package on our Mac workstation because we need to use boot for Docker or boot to Docker because we're on a Mac. So that really is the virtual box. That's VirtualBox that's hosting that Docker virtual machine. And then we kind of prepare our files, which is kind of standard App Engine development steps here, where you have your YAML file that defines how you want your workload to run, and then you have your code, which I've just got represented in a couple simple code examples, which we'll take a look at. And then to test that out, we just deployed that to the local environment. We'll actually try that here. And then we just tested it locally, and then we deployed it to App Engine. So those are kind of the steps we'd gone through to make sure the demo kind of worked. And so what I have really is the picture we showed here, where I've got one project. I've defined two modules that are going to be deployed and run first locally, and then I'm going to deploy it to the cloud after I see that it's running. And those two compute types are going to both have direct API access to the data store where all my event data is. So one of the challenges we had was event processing works really well in App Engine and can scale up and down. And like I said, the predictive workload, not so good in App Engine, works good in a managed VM. But the predictive analytics needs to be able to access the data store to pull back data and do its computing. So it needs to somehow be shared. And the other alternative to this, which would be much less performant, would be an HTTP type API access, which is available, but for the performance that we're looking for, just won't work very well. So let's see, I'll see if I can minimize this. I'm just going to follow my steps here that I have outlined here so you can see exactly what I'm doing. So we're going to, well, first of all, let's just do a Docker PS. So Docker is up and running here, and we've got nothing fired up here at the moment. You can see there's no containers. So if I just do a, let me show you these files real quick first, so you see what we're doing. So first of all, I called this one sandboxed module.yaml. Oh, here, I'm in the wrong one. There we go. Much simpler. Sandbox module.yaml. So this is our App Engine directives really telling the platform, here's what we want to do. So we're telling it things like, I want to use the Python runtime. I want to use my compute instance increment. I want it to be an F1. If we know we're doing heavy load stuff, we might just say, just start with an F4, use something much bigger. And then we're defining the maximum number of instances that we want to run at one time. So scale it up to 20, but just hold it there. Just slow things down if you need to, because we don't want to pay for more than 20 instances. So that's what this file kind of provides the platform. It gives the directives of how we want to run our workload. So and then we have an application called sandboxmodule.app, which if we look at it, it's real simple. It's a hello world kind of thing. So it's sandbox, so it doesn't have access to the file system, doesn't have access to any other libraries. We're kind of limited in terms of what we do there. Great for web serving. The manage VM module, we have a YAML file here that has a little more information in it. We're telling Google what we need for CPU and memory and disk, and then it's picking a size for us. And we can also tell it how many instances we want to scale up to, and some other kinds of things. We can do port forwarding once we get into configurations of containers. That's useful. And this application pretty much does the same thing. It's kind of a little, does a hello world, but then it also says, I'm going to try to list out what I see on the local disk. So something we couldn't do in App Engine in a sandbox container, but we'll just see if we can do it on the managed container. So any questions about that? Just trying to show you a little bit of the directives and questions. Oh, so I'll show you when we look at this running, you'll see that Google will kind of scale instances of computing. So we're kind of picking the increment of compute that we want, and then App Engine will scale that. So we'll see that we go from maybe 0 and then up to 20 compute instances if we give it some load. And I can actually run a demo to show that, so you can kind of see how that works. Yeah, he was wondering what, in the directives, what instances meant. You can set max number of instances. Do you have a question?
I guess to repeat it into the mic, in your config file here, you specify half a CPU, and I'm just wondering what that means in context.
Yeah, Ray, do you want to help me with that one? Do you remember what that means? Smallest core available. Yeah, there's some pretty good documentation when you're trying to configure this to kind of understand what your options are. Other questions before I move on? We got about 10 minutes here, so.
Docker, when you run your applications within Docker container, you are essentially running a VM or a runtime that is running all of your infrastructure, applications and everything. How reliable is Docker runtime? What if it crashes? Essentially, it's a sort of a VM, right? Is that correct understanding?
Well, so the way it's running here, yeah, it's running in a VM, yeah.
Right, but when you run it within App Engine, you are essentially running a Docker VM on top of an operating system. They don't call it VM, they call it runtime, but essentially it's some sort of virtual machine.
So it's I would think of it much like Compute Engine in terms of it being a virtual machine.
Right.
That Google said, you're not going to build it yourself. You're going to say, at least that's the way I'd do it. I'd say I'm just going to take one of them that Google's already built and tested, and it has the Docker extensions in it. It's capable of Docker, and so if it's been tested and provided by Google.
Right. So I don't mean virtual machine meaning operating system virtual machine, but like JVM sort of virtual machine. So one concern that I'm not able to get past is I am running operating system on a VM. Then if I run Docker, that is some sort of JVM sort of runtime or virtual machine. On top of that, if I run JVM, that's yet another virtual machine. How many layers of possible breakpoints am I introducing is the question that I'm not able to get past, and I'm going around with it.
Concerned about stability. Then,
right. That's
okay.
Oh, it's a kernel extension. Okay.
And then Docker wraps that and makes it more user-friendly to use. So the idea is you're sharing all of the kernel level stuff that the host OS would be using, but you're putting permissions around like sections of the file system or sections of processes so that they can't access other containers. They can only access the processes related with what's running in their area.
So it is extending the kernel, it's not a JVM sort of runtime. Okay. Thank you.
Yeah, there's a lot of concerns about people misusing containers and having kind of a constellation of containers that the way the Red Hat people, I saw a good presentation on it. They just said containers don't contain as their tagline. So be careful about what you're running together. It needs to be kind of trusted if you're running containers. There's a lot of details that we probably don't have time to dive into here, but it's being widely used, and I don't think there's any real concerns. I mean, you see really fast startup times for your workloads, which is really the benefit, and I don't think there's any real stability concerns per se. I think there's a lot more security concerns right now. That's a lot about what's been talked about.
So because it's using the LXC, you don't need, say, VirtualBox installed like you would with Vagrant. You can just have it installed on Linux, and it'll run locally like that. Okay.
Yep. Yeah. Okay, so let's see. We've got Docker up and running. So now what I do here is I just tell Google, I'm going to tell it basically I want to preview this. I want to run my two modules that I've configured in that YAML file. I want to run those locally and just see if that works. So let's give that a try here. So there, I just started up those two Docker containers, and now if I go over and look here locally, localhost 8080 was one of the ports. This says I'm the sandbox container, so that means I'm the App Engine container that has limited access to the system. And if I run 8081, the other module, kind of saying I'm here, and I can also list the contents of what's on disk. So just showing that we're in an environment that's not sandbox. So I could add whatever other libraries and that I wanted to get native access to all the App Engine APIs that I need, like data store, but also do some other things on the same compute container. So then the step after that would be just to push that out, and that's a command. It would just take a little while to push that out to Google's cloud. And here I've got that pushed out here, where I can just see the same thing. Now it's running. Now it's Google's cloud hosting those two containers. So I think one thing. Let's see. What do we got? Maybe 5 minutes. Let me just show you real quick, just so you can get a sense for App Engine. And let me refresh this. This is kind of the old App Engine console, but it works better for some things still. But I think I think the really important thing to understand is just how quickly containers start up and what the benefits are. VMs take quite a while to start up, and containers are really fast. And this is the same when I talked about the very first application we wrote. It was kind of fit this requirement. We've got 10,000 users that someday are just going to start hitting our system, and we don't know how many of that 10,000 are going to hit. But we really don't want to pay for any compute, throughout the year when we don't really need the compute. But we got to make sure we can handle all those requests that occur whenever they might occur. So this is that application here. I'm just looking at it in App Engine, and I can just shut down some of these containers. I think I ran a test here, so it left a few up. It's kind of interesting to look and see how App Engine does its scheduling, because this wasn't running for many weeks, and so it had taken it down to nothing. It had no compute there and ready to serve. It just said, there's nothing going on here. I'm not even going to make you pay for anything. But I pounded this thing just like 24 hours ago or less. And so it's kind of deciding, like, do we want to believe that there's nothing coming for many days, or should we kind of keep a little bit active here and be ready to serve? And if I left it till tomorrow, I might see it drop to 2 instances, and then it would drop to, maybe back to nothing again. So here I've shut down. You know what? I'll just shut down the last one too. So this would be like we've been running idle for 300 days. There's been nothing happening, no requests. And all of a sudden, we sent out all the notices to all the participants in the event that we were going to, for all their information. So they all get this email at the same time, and they all go and click the link. So this could be, I just put between 1 and 10,000 clients, just all of a sudden hitting my machine. So what this test does, because if this works, then I can be pretty confident that our actual users probably aren't going to hit it any faster than this. I'm going to say, let's just run between 1 and 10,000 client requests over 15 seconds. Let's just pound it and see what happens and see if we can handle that load. So that's what this test does here. So we're going to basically just go hit our sandbox container and just give it a lot of load all at once. So we're at zero compute instances at the smallest increment of computing that we're allowed on App Engine, which is called an F1. So here we'll just run this test. So it's getting the test ready to go. And then we can kind of watch and see what it's doing and what the timing is. And so 15 seconds, we're just about done. And so we can go over here now and we can look and kind of see what happened here with our load. So looks like, we ramped up very quickly. We decided we needed to ramp up some more. This load test was kind of giving that variable client load over that 15 seconds. So now if we go over and look over in App Engine, let's just refresh this. You can see it just fired up, all those instances to handle those requests. So that very first request, that's really the amazing thing, is how quickly the first request is handled. Not that once things are up and running and it's starting to, use its logic to scale things up, but that it can react that quickly and process that first request that quickly. It's a good example, I think, of the power of just the efficiency of containers and how they work. So. Any question? And I can just start killing these instances now if I want. It doesn't impact my ability to handle any requests that come along. Question?
And does a DDoS attack on your
Yep.
Server? What is going to happen?
Well, so it kind of depends what type of a service this is, but so my first line of defense is Google, because they've got a huge security group that looks for these things, and I don't understand exactly what they do, but I just know that it's a huge concern of theirs, because something that can really hurt my application can also hurt their infrastructure. So that's the first line of defense. If this is an API call that I have, then I have security behind that, and I need to secure my API. There's probably lots of other ways that I could, kind of protect it from. I'm also, in the directives that I give to App Engine, I'm telling it the max number of instances I'm willing to handle. So it's not going to keep adding indefinitely. It's eventually going to be per performance, at which time I would get a notification of a problem, and I'd start looking into that. Why am I seeing performance that's not what I expect? So I got just a couple minutes. Go ahead.
You mentioned that firing up container is much faster than VM. What is it doing? Because you have to boot the operating system, right? So what is it doing? It is not booting operating system?
So the host operating system's already up and running, and I'm just telling the container manager start this workload, and it can do that much faster then I can bring up a virtual machine. Like, Ray, do you remember when we did this test, we were looking at the timing of how long it took to bring up the container versus the VM? Because in that demo I showed, one was bringing up an actual VM, because with managed VMs, we're bringing up a VM.
Right. So in case of managed VM, you are paying for the VM. Here, Google probably has a bunch of VMs fired up.
Right.
And you are not paying for the VM, but you are paying for the container.
Right.
And
exactly.
containers are being, because there's a certain rule of gravity, right? You cannot defy that. So I'm assuming that Google has a bunch of VMs fired up, and if they have too much workload, it will take time for them to fire up new VM and then fire up those containers on top of that.
Yeah, although just technically Google runs their containers on bare metal, so that's a difference in the way we're able to run containers. But
okay, someday I want to understand, so I'll probably
I know it's confusing.
More.
And here,
Thank you.
Just in the last minute here, let me just throw a little more confusion at you, just things to study up on. So we just talked about one thing going on in the container world within Google, and that's managed VMs, which is really, if you're the center of your universe, like Augusto's is App Engine, then managed VMs is where we start. That's awesome. It helps us in a lot of ways. But if you're, sorry, I got to get to my. So if you're not into App Engine and you're more into your own infrastructure and doing Compute Engine, then you want to be looking at container optimized VM. So this is where I can fire up a VM that Google's provided me, and it's Docker ready to go. And here's how straightforward that is. One page, you can probably do this in about 5 to 10 minutes and have a optimized container up and running, which means a Compute Engine instance that's ready to go. I can start firing up Docker containers. I, basically pull down the SDK. I pull down a VM that's already configured for Docker. I SSH into it, and I'm ready to roll. So they're providing optimize containers to be able to access Google services, so I don't have to go figure out how to configure all that. It's just ready to go.
So, a few years ago, I learned about the app engine, right? At that point, I was like, well, this is good, but when I'm running software, like Image Magic is when the tools are running, I'm like, no, I can't really do that if that's
Right.
the core of my app, right? So I stuck with AWS.
Yep.
Anyway, a year and a half ago, whatever, maybe it was a year ago, I heard about Compute Engine, and that's kind of closer to what AWS is. It's like
Correct.
spin up your VM, run whatever.
Right.
What I learned today, I think, is, correct me if I'm wrong here, is, okay, on an app engine, I can potentially deploy Docker, therefore I get compute engine-like functionality. Like, whatever I learned about app engine initially, that I couldn't run Image Magic, is it true that now I can spin up a Docker running Image Magic and deploy it on app engine?
Yeah, it is. Yep. And that's really what that demo showed. In that managed VM, that could run your ImageMagick processing and still have access to my native access to my data store and other cloud platform, components that I need to access. Well, it just depends what you're into and how you go about things. If I'm writing by the way, it's past noon, so if you need to run, feel free. We'll just keep chatting. If my requirement is that I need to build a system that I can pick up and move over to Amazon or move over to some other platform, then I got to be careful about how tied in I'm getting into Google's APIs and their capability. There's a trade-off there, right? So I want to use services like a data store that when I save my data, it's immediately all over the place. I don't have to worry about replication. I know that my data is safe and it's good. And
hey, Paul, can I mention one thing real quick as you're wrapping
Yep.
up? Just for everybody that's still in the room and wants to talk more either with Paul or anybody else on our development team, we're going to be upstairs in the lunchroom, and we'll be happy to chat more with you about any of these questions you have about containers. And also, we're hiring, so if you want to come up and talk to us about what we're doing in our day jobs, which is pretty interesting because we leverage a lot of the technology Paul's talking about today and products that we build, and also the Google ecosystem, come up and chat with us. Happy to show you some examples of that stuff and talk more about it.
Yeah.
Okay.
So where's that question? So what I didn't get to cover here was container management with Container Engine is implementation of Kubernetes. I could probably do an hour presentation on just Container Engine and Kubernetes, but this gets into more of the world where I want to be on Compute Engine. I want to be managing my own configuration of containers. If you just think about Google's challenge, they got 2 billion containers out there running in their system. How do you manage that? Like, where are the containers? Are they running correctly? Which ones are involved in what workloads? You have to have some kind of a management system, and that's really what you'll hear. Container Engine is Google's implementation of the open source project that they started called Kubernetes. So container management is kind of a whole other topic. Maybe we'll take up next time. Yeah. Scale it down, yeah. With auto scaling, Google can scale up and down just like a sandboxed instance. It can scale up and down those Compute Engine, automatically. Yeah, that's called Autoscaler if you want to read about it. Yeah, thank you.
Files out to like the App Engine. So when you said the App Engine containers, you meant like an actual like Docker container or like an App Engine container?
So it's
Trying to, well, I guess because you said so, like it seems like it's like some people just use Docker basically just to like